Welcome to DataCentIR's webinar. It's high noon, it's hot outside, it's a Friday, and it's the 24th of June. Hope everybody's having a great day today. We don't want to waste any of your time. We're going to go through this PowerPoint and show you some cool video and different things, and hope you find this interesting. So in 2006, which is the last time anybody bothered to check, servers and data centers consumed 61 billion kilowatt hours, or 1.5% of the total U.S. consumption. That was 5 years ago. Projected consumption by the end of 2011, 100 billion kilowatt hours. Now, let's say that you're not so focused on being green, worried about the electric grid capacity, climate change, or let's say you're not even interested in how much the power bills are at your data center. You're still interested in thermal mapping, and is your data center overheating? Now, overheating data centers cause downtime, increased electrical use, equipment wearing out before its design life. Now, the IT department, the facilities management, and the business management all need to buy into the idea of reducing the heat in the data center. I don't need to tell you how mission critical your data center is. You probably already know and have somebody breathing down your neck if anything ever goes wrong. So it's worth millions. Now, there's two ways that infrared thermography in general, thermal mapping, and electrical, mechanical, predictive maintenance, the things that we do, there's two ways that we can help data center operators. One is the cooling systems and the heat generating equipment. And we have a product called Thermal Map, and we're going to show that today. The other is electrical, mechanical, predictive maintenance, and we're going to show that next week. We're going to do another one of these, and we're going to show it. So I just want to touch on the fact that even though we're living in 2010, most data centers are still cooled by hot aisle, cold aisle configurations. The bottom line is the cold comes up, the cold air comes up and goes into the inlet sides of the cabinets, which are opposing, into the cold aisle, and the heat blows out the other side up into either a ceiling or into some ventilation systems that return it back to the crack unit. Now, the problem with this can be that the perforated tile floors are not perfectly designed. The loads change in the systems, and it may have not been perfectly designed. On top of that, as you well know, contractors usually don't build it the way it's designed. So somebody comes with a change order, they're going to put some power cables in, they're going to run some things. I've opened these floors up many times and found people's lunch, found boxes of nuts and bolts, tie wraps, just anything you can think of, just piled up in here blocking the floors. CFD, we do a lot of CFD in our companies. There's 3 companies, but we do a lot of CFD. We don't do it, we only use CFD to calibrate in data centers, to calibrate what we're doing and to refine it. So we're using the infrared to look at the CFD and see how accurate it is. You know, CFD can make some beautiful pictures, but it is not reality. It's not reality. It's the way you design them. And so one thing that's great about what we're doing is that you can take a snapshot, and it's only a snapshot. It's not continuous monitoring. I'll get to that in a minute. Using the 3D imagery, you can calibrate and see how the model is being done, adjust the model, and make your changes. So the bottom line here is that somewhere in the data center, there's a piece of equipment that's going to fail at the lowest ambient temperature. So that's why you don't raise the ambient temperature in your data center, because you're worried about that failure. Here's an infrared picture of a floor. This is a typical floor. You got different kind of perfs. You've got different airflows going on. You've got cold spots, hot spots. The temperatures are all over the board. So what we do, and we do it for not only this dimension, which is if you rip the roof off and look straight down in, it's called nadir imaging. And straight down, what we do is we take a whole bunch of pictures straight down with this rig, and we mosaic this stuff together. We do that on 3 dimensions. So just backing up a second, how and why did we get where we are today? So sorry. Yeah, we've been doing infrared surveying of electrical and mechanical systems in data centers for over 20 years. This isn't our first goat roping. Mostly what we've done in the past until a few years ago is predictive maintenance on electrical switchgear. It's very common. Almost everybody does it, and if they don't, they need to have their head examined. You don't want electrical failures just because of a high resistance connection being loose. So we're going to have a webinar on that use of infrared thermography coming up later, actually 1 week from today. So about 5 years ago, our data center clients started coming to us and saying, we need you to look at the computer room, the computer floor. Tell us what's going on. So what we did, what any good infrared thermographer thinking in 2D would do, we got out, we started walking around and looking at the floors and the racks and all sorts of places. So we could walk what we call down the aisles and shoot this oblique imagery, but it didn't give us the picture and it didn't give us the answer. All we got was a bunch of small micro views. And where there is a value into shooting these type of images, because the heat from the servers actually impinges quite well on these kind of surfaces, as you can see from this picture. And there's data, there's things that we want to know about it. And so we use these pictures, but they're just a very small part of the whole. And so, and we also know that, as you can see from the amount of reflection on this floor, I mean, you can see this panel right here. This is the heat from this panel. This is this right here. As you can see from that, It's too reflective to shoot at an oblique angle. So it doesn't give you the picture. So fortunately, our Stockton Infrared company has an R&D group. It's called IR Researcher. And we brought these folks in and also hired a specialist to develop a better way to collect the imagery, which is a tremendous amount of useful imagery there. And also, our challenge was to refine the methodology, the challenge of those fellows was to refine the methodology of collecting the data, indexing it, storing it, and the larger, harder challenge, which was to build an intuitive interface that you could use to virtually move around the building. And we call that, what popped out of that work, we call it the construct. All right? I don't have any Matrix movie music right now, but imagine it. All right, so what's the construct about? Well, it's our way of dealing with these huge images. And so what I want to do is I'm going to show you this, and it's a video, but it's almost real time. It's very close to real time. And I'm going to play this, and we're going to use this on our website also to show how this thing works.
Welcome to DataCentIR. My name is John Finlayson, and I am one of the technical directors. This is an introduction to the Thermal Map IR viewer. Thermal mapping produces a huge amount of data. The viewer is designed to provide access to the data with emphasis on 3 key goals. Context is important for organizing and accessing the data. The viewer uses a visual representation of your data center. This provides a familiar context for locating images. It also provides relational information for identified problems. Context also applies at the detail level. Thermal mapping captures thermal and photographic images of all of the equipment in the data center. The images are combined into groups. These include the complete side of a row or the entire floor or ceiling. Combining these details allows for the visualization of proper operation and anomalies. Ease of access is critical for effective use of the thermal map. We provide intuitive icons and preview images so that users can quickly understand what is happening in the entire room. These icons control images of the server cabinets. Thermal and photographic images are synchronized for each face. Front and back or right and left aisle side options are available. Single sides with greater detail are also provided. Icons for the walls and down the aisle shots control those images. Synchronized images are provided for the walls. Down the aisle images include photo, thermal, and map images. Pop-up thumbnail images allow for quick previews while exploring the data. Clicking the icon brings up the detailed images. Up to 4 images are presented for each location. These images can be scrolled and zoomed. All of the images are synchronized so that the same equipment is shown for each image. The single-sided images work in a similar manner. Single-sided images allow for a more detailed examination of any given location. Down-the-aisle images can provide important information about a data center. They capture the heat signatures on the rack grids. This helps to understand airflow. They provide a limited but useful depiction of the floor-ceiling rack interaction. The interface provides a compass that can be used to jump to neighboring locations. A map, photo, and thermal image is provided for each location so that it is clear where the data was gathered. Images of the walls are important for understanding the status of the room. Problems such as inadequate insulation and defective equipment can be detected. The floors and ceilings are captured and combined into single images. These can be compared and examined in detail. The floor and ceiling images are also presented with map images so that the details can be located against clear references. At the end of the day, it is important to understand what you can gain from creating a thermal map. Here are 3 examples. This floor map allows for several findings. There is a blockage under the floor that prevents adequate cooling of the rightmost line of servers. There is overconditioning in the lower left corner. This could allow for reducing energy costs. It could provide a place to add new high energy density equipment. It helped to find that a crack unit was low on Freon and how the cycle plan interacted with the floor blockage to lead to inadequate cooling of the most critical servers. The servers in this image are functioning in a normal manner. In each rack, a router has been placed to make wiring easy. This resulted in the routers using the exhaust air from the servers for input. As a result, the routers are operating at a very high temperature. This one image identified a failure situation that threatened $32 million in equipment. Welcome to DataCentIR. My name is John Finlayson, and I am one of the...
I hope you enjoyed that. I think you got the idea, and you can also understand why we recorded that. It's got a lot of components. We wanted to get it clearly and not waste your time. And sometimes on these net meetings, the speed of the connection and the speed of your connection will hold us back from being able to do some things. So what I want to do now is I want to go and show you, and if John would like to, I'll open this image demo. And as you can see, you can flip back and forth between infrared and visual. You want to describe this, Mr. Finlayson?
Yes, this is a cubic image that was taken in a data center, and the primary reason for doing it was because the ceiling is what we call a 3D ceiling. It's got lots of equipment hanging from the ceiling, and the components in there could potentially be problems, so we want to document them. But using the cubic images, we get the complete context and not just a snapshot of a particular area of interest.
Okay, I think you get the idea. And for each one of these images, we have a visual and an infrared. So, and then you pan around and fly around and go anywhere you want in the building. Okay, so now I'm going to show this. This is a little bit of a monster here. If you could, John, explain here what we're looking at.
Well, one of the challenges is what do you do with somebody who has a 100,000 square foot data center? And so this is a simulation of what that kind of a presentation would look like. Again, we have a situation with a 3D ceiling, so we want to get this overall context. And once inside the viewer, you're able to look around at any orientation, and then you can click the button on the upper left, and the images will switch between infrared and photographs. In addition, the compass allows you to move in the directions that are indicated so that you can navigate around the room. And this particular application is being integrated with the viewer that was shown in the video so that you can pop into the viewer at any location that you choose to, in addition to being able to wander around once you're in the building.
Okay. Now, I'm going to go over these all in just a minute, but I also wanted to show our website. Here's the home page. And from it, you can go and look at the electrical maintenance, electrical mechanical maintenance, the 2D imagery, where you got the side-by-side, the 360s, cubic images, and the 3D mapping. And, if you turn your machine on HD and then just play this, you'll see how it works. Basically, you can, once you build the construct, we can paste all this right into a way so we can look like this. You can see the ceiling. You can flip the thing around, where everything is. And it's all scalable. So we can make it as big or small as we want. We can take out whatever component and put in whatever component, put in the visual and the infrared. And so that's the idea there. So let me just go back to this PowerPoint for a minute, as we promised a half an hour, and we're not going to go over it by 1 second. Again, big problem in these data centers is the hot aisle, cold aisle, because it's really supplying the cold air that's going into these racks, and that temperature of that air that's going to the inlet, there's your weakest link. As I showed on the website, the 2D imaging is basically doing this kind of thing right here. It's really very intuitive. You just roll your mouse. If you've got a roller mouse, you just roll the mouse in, and it zooms in to where you could, like, read the newspaper. So this particular data center, which we showed, he showed before, John showed before, has a obvious problem. It's got a pipe that's running through here. What's remarkable is that this has a brand new control system in it, and they didn't know that this machine right here was out of Freon. I'll show it in a minute. Now, how do you fix this stuff? We have technical experts that can work with your HVAC contractor or your technical experts and figure out what kind of perfs need to be in these floors, how you can rewire it, how can you move things around, whether you need to put fans in, all that kind of stuff. But what this thermal map of the whole place at once, it's a moment in time, one place, tells you a lot of information. And this navigation system is what we really cracked the code on, how to collect it and use it. Same thing with the servers. We got straight on shots of the servers that you can zoom in and read the wire. So one of these, and I'm not sure which one it is here, but we talk about it on other webinars or seminars, but one of them, the servers are backwards. So they're blowing hot air into the cold aisle. I mean, things like this, whereas no matter how big your company is, no matter how smart the people are in the place, you don't know every temperature in your data center. And so what we offer is to come in and be able to show you all those temperatures at once. This is that one, the Freon's low in this. Also, another reason for shooting the walls is that some of these machines, some of these data centers have outside walls, which is not that bright an idea. But they've got outside walls, and then they've got maybe a metal deck, a couple of inches of insulation, maybe some foam insulation, some TPO that is supposed to be a green roof. It's not. It's not that well insulated, and it has a lot of air leakage problems. So knowing what your building's doing thermally is a very important component. And you know, like I said, we do these, I'm just showing these, the panoramas and the different types here. You know, going around this big place. And then the ultimate is to put the thing into the 3D model so you can spin it around and do anything you want to with it. So we have 5 minutes left, and so I want to, first of all, I want to thank you for your attention. And I got a couple, I ran through the registrant questions and answers, and I pulled out some stuff that I thought you'd be interested to know. Out of I think we had 40 or 50 people to register. Out of those people, we asked the question, do you think you have hot or cold spots in your data center? 90% of them said yes. If you answered yes to the question above, has the CFD model been updated? 88% answered not sure. In case you're wondering, that means no. Other than I like my job, why don't you raise the set point of the ambient air in your data center to save energy? 95% answered don't know, not sure, good question, and things like that. Was your data center designed using a CFD modeling? 64% answered not sure. What is the temperature set point of the ambient air in your data center? I was surprised to find we only had 6% heroes over 80 degrees. They got the bravery there going. 20% said 66 to 70. That's really no surprise. In fact, I thought it'd be higher than that number. 70% said 71 to 75. Now, here's the next slide really tells you what this is, because I compared the numbers. So what temperature could you raise the temperature to before you feel that you'd start experiencing heat problems? 80% would risk raising the temperature less than 5 degrees before they thought they would have problems. I'm not that surprised with that either. So there's 3 minutes left. I got time for 2 questions that popped up. One of them, okay, what about real-time monitoring of the data center with thermocouples? Okay. First of all, I think it's a good idea to do real-time monitoring. But I think these data centers have got just about enough wires in them. Go get yourself a wireless system. In fact, this morning, I read an article where Vigilent, it's Vigilent, installed their system in Verizon data centers. And here's the quote from the guy from the Verizon, Mark Capurso. He says he's the director of national technical operations. He says Vigilent energy management systems have reduced cooling consumption by 40%, as well as provided important safeguards that help improve our uptime. This combination of energy savings and improved efficiency goes a long way toward helping meet Verizon's goal of improving its carbon efficiency by 15% this year. That's pretty impressive. Those guys are actually thinking green. And so how does I'm sure that Verizon did their homework before they put it in, but they had to take a certain leap of faith to install this system, at least in a pilot study. So what does Thermal Mapper, our product, do for people like Verizon? It lets them know that there's enough low-hanging fruit without going to the expense of installing all this equipment and monitoring it from whatever, and so that they can see whether or not it's worth putting in the systems. Probably it is. Every one that we found we had problems on. They had a lot of problems. In fact, this Vigilant company ought to hire us to go to every prospective customer they have for a super complete shot of the potential savings as like a sales tool. See, I got one more question. How do you price your services? We look at a lot of things. We look how big the place is, what granularity of data that we need, which products we need. As you can see, there's a bunch of different products, and so I've got a slide here that I had hidden. Let me see if I can put it up. 1A, level 1, thing A that we do is we want to learn more about the facility. So we go to the facility, or we talk to somebody on the facility, or we do a net meeting, and we get some pictures of the place. And so our first step is consultation. Then we look at the drawings, the loads, the HVAC setup, the timing, when do their loads come in, and those sorts of things. And then we customize the surveys based on that. So I can't tell you a per square foot price or per hour or anything like that, but if you're interested in learning more, you just call us. And I want to make one program note. I'm right up against the time. One program note. If you want to know about this electrical and mechanical PPM, we're going to do, you'll get one of these invitations, and you just click this button. But we're going to do this 1 week from today. And so I want to thank everybody that's been on the call. Thank you to Eric Stockton and John Finlayson. And just call us up, go on our website and hit the info button, or email us, techteam@DataCentIR.com. So I'd like to tell everybody that I know it's hot outside, and it's Friday afternoon, and you're looking toward the door. So have a great day and a great summer, and I hope to see you next week.